Assessment 1 in wireless network technology. Assessment 1.1. The things that we are discussing are protocols. A protocol is a set of rules that governs the communication between network devices. Such protocols enable the devices to communicate regardless of the underlying network infrastructure, topologies and the designs. Few of such protocols are HTTP, IP, TCP and UDP. And the organizations that voluntarily develop and establish technical standards to address the needs of the group of affected adopters are called the standard bodies. Example for such standard bodies are IEEE, IEEE-like organizations. Subsequently, some of these standards may become legal requirements. Forums are made up of representatives of interested corporations working with universities and users. These representations test and evaluate the standards of new technologies. Examples for such forums are ATM forum, frame relay forum. The next we are going to discuss about ISO OSI network module, which consists of 7 layers. First layer, physical layer, deals with the physical attachment of the network by transporting data using electrical, mechanical or procedural interfaces. This consists of the combination of software, hardware programming and also covering the variety of devices like connectors, cables, transceiver like that. The second layer, data link layer, determines the path. It concerns with local delivery of frames between nodes on the same level of the network. A further data link layer has 2 sub-layers, logical link control and the media access control. Layer 3 is known as the network layer. It adds destination switching, routing and relaying functions and present these in a manner which is independent of actual networking use. Network layer is responsible for logical addressing and routing functions. Therefore, IP version 6 and IP version 6, IP versions 4 and IP version 6 are working in this layer. The next layer is transport layer. It provides user-to-user service including multiplexing, and also it enables effective use of network facilities. And the transport layer is the one which is responsible for process-to-process delivery of the entire message. And the underlying protocols used in transport layer, UDP, user data protocol, and transmission control protocol. Next layer is the session layer, layer 5. This builds the transmission bridge as a way to organize simultaneous communication of multiple network applications. The protocols used in this session layer: short message, peer-to-peer SMPP protocol, point-to-point tunneling protocol, etc. Layer 6 is the presentation layer. It is responsible for delivering and formatting of information to the application layer, and also including the interoperability of different encoding methods, encryption and compression of data. How the data is presented is done at this layer. We can say Telnet as an example for this example protocol working in this layer. The last layer, the topmost layer, is application layer that provides the interface to the user application and almost the common services such as file transfer, electronic mail, those things are working in this application layer. And we can further consider this application layer as an abstraction layer of the OSI module. Like this, bandwidth refers to the speed of bits transmission in a communication channel, which is measured in bits per second. Throughput is the actual measurement of the link, and latency is the amount of time taken for the message to be delivered completely. The parameters in digital signals are bit rate, bit length. Bit rate is the number of bits sent in 1 second, expressed in bits per second. Bit length is actually used in digital signals. That's the distance that one bit occupies on one path. Assessment 1.2.1 focuses on the following things. Line coding is the process of converting digital data into digital signals. Actually, it is the sequence of binary digits that represent digital data which are converted to digital signals. The line coding process is usually chosen to avoid distortion of signals. Also, line coding specifies bit clock recovery utilizing bandwidth, and it has an error correction capability also. Line coding has some popular schemes such as unipolar signaling, polar signaling, bipolar signaling, and Manchester signaling. PCM stands for pulse code modulation, which measures the amplitude of an analog signal at regular intervals and converts that into a binary code, and each sample is quantized into the nearest value within the range of digital data. The PCM encoder has three processes: sampling, quantizing, and encoding. And there are different types of modulations used in converting digital signals into analog signals. The first one is ASK, stands for amplitude shift keying. The amplitude of the carrier signal is varied while the frequency and the phase remain unchanged. FSK is the frequency of modulated signal is constant for the duration of one signal element and changes the next signal element, remaining amplitude and the phase unchanged. PSK stands for phase shift keying. The carrier signal is varied to represent two or more different signal elements while remaining the peak amplitude and the frequency. These are two modulation concepts in analog signals: amplitude modulation and frequency modulation. Amplitude modulation is the technique used to convert audio frequencies to radio frequencies. This modulation is done in long distance communication, and actually this is the simplest form of modulation. And frequency modulation is the technique that varies the carrier signal frequency in proportion to the amplitude of the carrier signal. Bandwidth refers to the speed of bits transmission in a communication channel, which is measured in bits per second. Throughput is the actual measurement of the link, and latency is the amount of time taken for the message to be delivered completely at the destination. Time division multiplexing is the technique applied in digital signals by dividing the channels on the basis of time instead of frequency, such as in FDM. Total time available in the channel is divided between several users, allocating a particular time slot for transmitting data for each user. There are two techniques in TDM, time division multiplexing: synchronous TDM and asynchronous TDM. In synchronous time division multiplexing, it is working by allocating same amount of time to transmit data for each user. It doesn't consider whether the device has data to transfer or not. Even if the device doesn't have data to transmit, the same time will be given, and that will be remain empty if there's no data to transfer. Therefore, it does not guarantee maximum utilization of the capacity of the channel. Compared to that, asynchronous TDM, which is also known as statistical time division multiplexing, the time slots are not fixed. Instead, time slots are allocated to the devices dynamically only when they have data to send. So therefore, it allows for full utilization of available bandwidth of the channel, and also it eliminates intermodulation, distortion and crosstalk. The next topic that was discussed in assessment 1.2.2 is spread spectra. This is the technique used in wireless applications, wireless LAN and wireless WAN. In that, a signal is generated with a particular bandwidth is deliberately spread into the frequency domain. Now, the results of this is the signal will be in a high bandwidth. The process of using spectrum techniques to establish secure communication and to increase the resistance to natural interferences, noise and jamming, etc. And actually this is applied in wireless communication. Spectrum technique has two technologies. It uses two technologies. FSS stands for frequency hopping spread spectrum, and the other one is direct sequence spread spectrum, DSSS. And then we focused on different transmission media, few of them. Twisted pair copper cable, consists of two copper conductors twisted together, and these cables transmit data at a very low bandwidth with high attenuation, but they are the most cost effective cables in data transmission. And there are two categories of twisted pair copper cables: UTP, unshielded twisted pair, and STP. UTP, the standard connector for UTP is the RJ45, and shielded twisted pair is having better capability of resisting to noise than UTP. Another transmission media is a fiber optic that consists of a center glass core surrounded by several layers of protective material. So therefore it eliminates the electrical interference problem, since it uses it's based on transmitting light rather than electrical signals. So it's the best solution for long distance data transfer at a very great speed, but the cost of cabling is very high. Now this fiber optics are used in transferring data at video streaming, video conferencing, and other interactive applications. Radio is the next media, which is wireless. Radio waves ranging in frequencies between 3 kHz and 1 GHz. And when transferring radio waves by an antenna, they will be propagated to all the directions, so that any receiving antenna can receive radio signals, and this is called omnidirectional. And radio waves are also utilized in long distance data transmission, such as in AM radio, in error corrections, Hamming distance, block coding, linear block coding, cycling coding, checksum, etc. Next we have discussed about the random access method. The first one is ALOHA. This is designed for wireless LAN in which multiple stations can transmit data at the same time. It is adhered to two technologies, pure aloha and slotted aloha. Another random access method is CSMA-CD, carrier sense multiple access collision detection. Now CSMA is a protocol used to control the flow of data in transmission media so that data packets do not lost. So we can maintain the integrity in transmission. CSMA ensures fewer collisions because it sends data only if the channel is ideal and wait till the channel gets ideal to send data. So this CSMA-CA, carrier sense multiple access collision avoidance, is collision is detected by receiving an acknowledgement signals by the sender. So, but if the sender receives two signals, then a collision has been occurred, and it avoids collisions by different methods such as interframe space collision, contention window, acknowledgement, etc. Frequency division multiplex access, in that the available bandwidth is in the channel is divided into frequency bands so that each station is allocated a band to send data. So as a result of this, each station is allocated a predefined frequency band for the entire period of communication. The next one is time division multiple access, TDMA, that divides the same frequency channel into different time slots so that it increases the capacity of the data carried. This allows multiple stations to share one channel without any interference. But TDMA is considered a complex technology because it requires accurate synchronization. And that's the end of the assessment 1 presentation. Thank you.